I want to talk about a few symbols that you will see in calculus, probably more than you have seen in previous math classes. They're not exclusive to calculus, they just tend to show up a little bit more because as we get into higher math, we tend to use more symbolic forms when we write theorems and such. Okay, so for the first one, this one right here means that something is an element of. Oops. Let me rewrite that. Okay, or is in the set of, all right? So you're probably familiar with this. Okay, this symbol means union. This one means intersection. Note that this is not the letter U. It does not have a tail. It just looks like a U, so it's easy for us to say U, but it actually is just a symbol because in set notation, these horseshoe shapes in different directions mean different things. But so if we turn that sideways, okay, we get that something is a subset. So like A is a subset of B. All right, and if we put a little line through the middle, sorry, my handwriting's not super great on here, but if we put a little line through the middle, we get this right here, which means that something is in the set of or is an element of. So I might say that 7 is in the set of integers, and a script Z like this is, again, kind of sloppy, but a script Z means the set of integers. So 7 is an element of the integers, or I could say pi is an element of the interval from 1 to 6, because pi is a number in between 1 and 6 in that interval. Okay, so that's the first one. This next one you may have seen in geometry, but a triangle of 3 dots means therefore. Okay, so it's just kind of a lazy way to say that I'm stating a conclusion. Okay. I'm going to move this over here because I'm running out of room there. All right, the backwards E means there is, or more often, there exists. Okay, so, and I'm going to use these as an example here, but that means in a minute, but this means there exists or there is. And then the upside down A means for every or for any. Okay, just depending on what makes the most sense grammatically when we're stating it in English. Okay, so for example, and this is from, I just took this from your Chapter 0 reference. Hopefully you've started looking over that. But this right here is a sentence in English, but it is written in symbolic form. Okay, so the script Q, remember I said the script Z is the set of integers. The script Q means the set of rational numbers. Okay, so script Q is set of rational numbers. All right, and then also the curly brackets, okay, mean that we have a set. So what this says is for any rational number, so X and Y are in the set of, or are elements of the rational numbers. Okay, and then the vertical line, I mentioned the 2 dots in another video because that's the notation that our textbook uses, but the vertical line or a colon means such that. Okay, so for every X and Y that are in the set of rational numbers such that X is less than Y, and then backwards E, there exists, okay, a Z, which is also in the set of rational numbers, such that X is less than Z is less than Y. Or in other words, this right here is saying that Z is between X and Y. Okay, so really that this is a theorem that's just written in symbols, but it's saying for any 2 rational numbers, there has to be another rational number that is in between those. Okay, for our purposes moving forward, the fact that that theorem exists, it is important because we're going to talk about like limits and numbers approaching things, but really what I want you to take away from this is the symbols, because you are going to see them, especially these 4 right here.